So welcome to today's most interesting topic in physics, waves. So you can say we have waves. Now, what is a wave? What is a wave? So by definition, you can simply say a wave is a traveling disturbance. Traveling disturbance caused in a medium. So when we talk of medium, we are simply talking about the solid, liquid, and gas. That's what it means when you talk about medium. Or the simplest definition that we can give to a wave is we can say a wave is energy in transit. So it simply means it is just energy in transit, and this is the most acceptable way of defining a wave for physicists, because it simply explains everything. If you define it in this way, meaning you have explained everything, then you also need to be aware of the types of waves. So types of waves we have, we can simply say there are two types of waves. So we have two types of waves, which is number one, we have longitudinal wave, and two, we have the transverse wave. So again, what is important is to know the definition of these two types of waves. So we can look at the first one, which is longitudinal. So what is a longitudinal wave? So a longitudinal wave, we are simply saying this is a wave in which particles propagates parallel to the direction of a wave. That's what it means. So there we are saying particles, they're supposed to propagate, or rather to move. So where there is propagates, you can also put vibrate, you can also put movement. So you can simply say this is the wave in which particles vibrate parallel to the direction of a wave. So now, you also need to understand, if you talk about the particles, these particles in longitudinal wave, how are they supposed to move? So the movement. So movement of particles. So movement of particles, of course, under longitudinal. So the way these particles move, if you have a particle there, meaning it will move in this direction, so back and what? Forth. Back and forth, or they can be in this format. So it's always back and forth. So we are simply saying this is the mover in the direction of sideways. So this is how particles move when it comes to longitudinal wave. So this is very much important, especially on the multiple choice part. You'll be asked to choose the correct diagram that shows the correct movement of these particles. So it's very much important you get to know those movements. So we can as well as look at some examples. So examples of longitudinal wave. So some of the examples that we can give, number one, we can say sound wave. Then two, we can also give an example of the spring. So waves on the spring. Then three, when you water. So if you're giving water as an example of a longitudinal wave, you need to be much specific, because this is also an example of a transverse wave. So when it is a transverse wave, meaning we'll say the water on the surface, meaning we need to be specific, we are talking about the surface. But if you're giving this one as an example of a longitudinal wave, it means you're talking about where water in the deep. So if you cause a disturbance on top of the water, those ripples you see, those are transverse waves. But down there, it means those are longitudinal waves. So you need to take note.